There's nothing more fascinating than watching the complexity of the solar systems and the galaxies. In this video, we'll be exploring two remarkable things: the newest multi-star system, TIC 29006144, and the first ever discovered triple-star system, Lambda Tori. So hold on tight as we take you on a journey into space. Just when you think you've seen enough solar systems, you wake up to another shocking discovery. Just recently, professional astronomers have made another groundbreaking discovery with the help of artificial intelligence, identifying a unique triple-star system named TIC 29006144. You might have a hard time mastering all those numbers. This magnificent trio is an identified star system made up of at least 3 stars, orbiting one another in perfect harmony. It was uncovered in 2023 through cosmic strobe lights observed by NASA's Transiting Exoplanet Survey satellites, TESS. This sure is an exciting addition to the small catalog of known multi-star systems. The TIC 29006144 features a pair of identical stars that orbit each other every 1.8 days, along with a third star that orbits this pair once every 25 Earth days. This insane finding breaks the previous record set in 1956 for the shortest outer orbital period in a system like this. That's a huge gap of 59 years. The last record had a third star orbiting an inner pair in 33 days. But we'll talk about this later in this video. Flickers from distant starlight helped astronomers to find the trio, which is located in the constellation Cygnus. Looking at it from our world, the system happens to be almost flat. This means the stars eclipse each other as they orbit. But a closer observation changes the narrative. Also known as Gaia 21693822087749630072, TIC 29006144 is located 4,954 light-years away from the Earth. To give you a clearer perspective, the Sun is only about 0.00001581 light-years away from Earth. Now that tells you how distant the system is from us. Dr. Veselin Kostov, an astronomer at NASA's Goddard Space Flight Center and the SETI Institute, had said that the orbits, masses, sizes, and temperatures of its stars can now be measured, all thanks to the compact, edge-on configuration of the system. They can also study how the system formed and predict how it may evolve. The scientists are still amazed at this trio system because it's an extremely rare discovery, and many more likely scattered in our galaxy, waiting to be discovered. Somehow, because the stars in the TIC 29006144 system orbit in almost the same plane, it's likely very stable despite their tight configuration. The gravity of each gravity doesn't disturb the others too much like they could if their orbits were tilted in different directions. We can speculate that the stars formed together from the same growth process, more like baby triplets growing at an equal rate. As the inner stars age, they will expand and ultimately merge, triggering one big supernova explosion, which will happen about 20 to 40 million years from now. How remarkable is that? Life as we know it is unlikely in this vast sheet of galaxies. These systems give us insights into the possibility of planets forming around it, and so this supernova explosion is unlikely to impact any life on planets around the 3 stars, as there doesn't seem to be any planets close enough to the stars to support the existence of life. Multi-star systems like TIC 29006144 make up a small fraction of all known stars, but they offer crucial clues into star formation and evolution. The discovery of the TIC 29006144 shows how limited our understanding of gravitational balance is, despite the unrealistic discoveries made every year. And surely, many more systems like this are likely to be spread across the Milky Way, waiting to be discovered. This event gave scientists more reasons to dive deeper into machine learning. as it helped them identify these patterns to discover more unique star systems. With a little more study, astronomers hope to understand how millions of systems like this are still somewhere in the Milky Way, and what they might reveal about the conditions of the early universe, helping them piece together a better idea of how stars and planets form throughout the universe. Earlier in this video, we mentioned the last triple star system to be discovered held the record for the shortest outer orbital period in a system, before the discovery of TIC 29006144. This triple star system is known as Lambda Tori. For Lambda Tori, the story is a little different. Discovered in 1848, the system was a marvel to astronomers of the time, who only used early telescopic technology and ancient tools to study its components. And this opened the possibility of more extraordinary discoveries. The light from this system seemed to change from time to time, and so it was determined to be an eclipsing binary system. This is only the third ever to be discovered. Now, what makes up this system is a combined apparent visual magnitude of plus 3.37 at its brightest, making it one of the brighter members of the constellation. Based on parallax measurements, the distance to this system is about 480 light-years, way less than the TIC 29006144. Like other star systems, the inner pair of this trio, Lambda Tori AB, orbit around each other with a period of 3 days and 23 hours, while the third star, Tau C, is orbiting the inner pair over 33.025 days. There is rarely any known constellation so loaded with bright and beautiful sights like Taurus. However, among all the systems that exist in Taurus, Lambda Tori is the most overlooked. It might shock you to know that Lambda Tau is close to the brightest of the obvious eclipsing double stars in the sky. Every 3 days and 23 hours, the Lambda drops in brightness by well over half a magnitude to around 4.1. This eclipse-like event, from start to finish, takes 1.1 days. The entire system is made up of a giant primary star, while its companions orbit within it in a tight pattern, giving the system a perfect rhythm. The two stars are so close that Lambda would somehow vary even when not undergoing its eclipses. Looking at the Lambda Tori, you can tell that the color is blue, which means that the star is one of the hottest stars in the universe, hotter than our star. Its temperature is in the range of 10,000 to 30,000 Kelvin, but its effective temperature is 8,336 Kelvin, which is almost twice as hot as the Sun's effective temperature. The interesting part about studying the Lambda Tori is that it's a naked eye star, so you don't need a telescope or binoculars when you look up on a clear night. The lower the magnitude during its eclipse, the easier it will be for you to see. What more do you expect from a 100-million-year-old star system? Every discovery changes the trajectory of future discoveries, and Lambda Tori has indeed set the ground running for the research of more multi-star systems. This has given astronomers more insights and a template of what to expect when looking out for similar star systems. The unusual radius of the secondary star in the Lambda Tori system suggests that the pair is a semi-detached binary. This means that the secondary star gives the system a more distorted shape. The more it evolves, the more it takes on a whole different shape. Scientists would never have known this about star systems if the Lambda Tori had not been discovered. Not only that, it provides a more elaborate explanation of the theories of eclipsing binaries. This happens when two stars are nearly in the line of sight. This causes one star to block the light from the other, and vice versa as well. For the Lambda Tori, the eclipse is very noticeable to the naked eye, which means you can see it from your window pane. With this, astronomers can gain a clearer understanding of other eclipsing systems. From the TIC 29006144 to the Lambda Tori, now you have a clue of what the outside Earth looks like. There are billions of other star systems lost in the cosmos, but with the understanding of these two, we now know what to expect. These systems have pushed the boundaries of our knowledge of stellar evolution. Imagine what the next Discovery multi-star system would look like, or possibly even more complex ones that would permit the formation of planets that support the existence of life. And who knows what the universe would look like from there? What other stellar wonders could be out there, waiting to be revealed? Stay tuned as we continue to explore the universe.